Through the revolution in electronics that man has nurtured during most of this century, nearly every consumer and industrial product has gained new control range and versatility. Since the very beginning, wire harnesses, such as this one, have carried messages between various electronics components in a product or system. Though the electronics that they join have evolved to nearly artificial intelligence levels, these neural pathways have evolved little, and in fact are still manufactured in pretty much the same way as they were 50 years ago. In wire shops, where wire harnesses are manufactured today, manufacturing and quality control methods have been finely honed to reduce costs. Because these methods are designed for larger runs, the larger the production run, the greater the productivity gains. But the reality is that long harness production runs are less probable than they were a few years ago. The end products that they go into are being built in shorter runs that are driven by just-in-time manufacturing and the desire to keep work-in-process inventories down. So productivity levels off, or worse, drops. What's more, with shorter production runs comes the likelihood that substantial design changes will take place between runs, increasing the costs of documentation and tooling revisions. So the fact is, to regain hard-won cost reductions at the smaller batch manufacturing levels and to reduce costs even further, the basic method of harness manufacture has to change. The Wire Vektor 2000 offers just such an opportunity. From raw components to finished kit assembly ready for routing, the Wire Vektor offers new wire harness manufacturing automation, providing on-demand production in aerospace and similar industries. The Wire Vektor efficiently manufactures high-quality kits for use in the final assembly of harnesses. The level of harness completion represented by a kit is dependent upon the user's selection of the functional modules that go into making up the Wire Vektor system. For example, in one of its smallest forms, the Wire Vektor produces a kit of wires where each wire is individually selected, measured, marked, cut, and contained in a material management container called a rillette. By further adding wire end finishing modules, each wire in the kit can be terminated, leaving only routing and connector insertion to be manually done. For improved handling efficiency, an added module stacks, indexes, and retains the rillettes in 50-wire kit totes. With the addition of an insertion module, the Wire Vektor builds a kit that has one end of each wire inserted into a connector. It's this modularity that allows any wire shop to take advantage of the Wire Vektor's fast throughput and consistent production quality. Because the Wire Vektor was designed from the ground up for a new approach to dedicated wire processing, it had to provide the uncompromised performance that would be unavailable with a universal robot. The consistency and accuracy afforded by dedicated mechanisms and computer control automatically build in quality. However, the Wire Vektor further ensures kit quality by inspecting the results during each phase of the process. Though totally new modules were designed to fit the system's performance and modularity needs, the best of proven commercial technology was modified and adapted where possible to contain system cost and increase reliability. Throughput rates for single conductor terminated wires are better than 15 seconds per wire for over 240 wires per hour. Even with the added step of wire terminal insertion into the connector, the Wire Vektor churns out more than 150 wires per hour. This new manufacturing technology is supported from a proven experience base of manufacturing systems development. For example, each of our Model 849 shock absorber quality assurance systems run continuously with very low mean time between failure, passing through over 20,000 fully tested products each day. Because over 70 systems have been installed worldwide over the last 10 years, millions of MTS-tested shocks ride the world's highways. Our Motion Plus motion control systems have automated multi-axis production machinery for over 10 years, providing productivity gains and consistent product quality to paper converting, metalworking, and plastics industries. Our Model 100 light manufacturing tool combines machine tool precision and advanced control flexibility to bring the efficiency of high-volume production to short-run routing and drilling processes. And on the leading edge of manufacturing technology development is our laser articulating robotic system. Here, multiple laser sensing systems precisely track assembly seams and position high-power laser welding beam delivery systems. These few examples from our broad control and mechanical design experience base also exemplify our long-term commitment to helping industry meet the challenges of this competitive world. This commitment is your assurance that the wire vector technology will meet your wire shop manufacturing needs now and in the future. Let's take a closer look at the Wire Vektor 2000. It's composed of three basic functional groups: wire containment, wire end termination, and kitting. These three groups are directed by Wire Vektor Control's host controller, a Hewlett-Packard Series 9000. High-level software running the system operates under Unix and is written in C, a universally accepted machine control language. In turn, a hierarchical architecture links the host to dedicated Motorola microprocessor-based module controllers for distributed processing of wire parameter data. Through this technique, the wire vector is able to process large quantities of wire data to maximize the throughput performance potential of the hardware. Programs of wire parameter information may be downloaded from a local area network, or may be loaded directly by the operator. If at any point in a wire's preparation, a wire is found to not meet specifications, the wire will be rebuilt and inserted in its proper location in the workstream. The wire containment section contains modules for wire despooling, selection, marking, measuring, cutting, and containment. Up to 16 spools of wire are kept under constant tension at a feed rate of 60 inches per second. Each wire is checked for splices as it unwinds. The containment section can process single conductor, multi-conductor, and shielded wires. Wire from one of the 16 spools is selected and drawn through this banjo selection arbor and capstan drive. The selected wire is marked with up to 18 alphanumeric characters. Here, ink is transferred from a foil to the wire by contact and cured by heat to mil spec. Capable of handling 16 to 24 gauge wire, the marker is also programmable for contact pressure, dwell time, and spacing between marks. As the wire is marked, it is also measured. Elastomeric bands increase the encoder drive contact area to improve wire feed control and provide accuracy to plus or minus 1/10 of 1 inch plus 1/10 of 1% of the cut length. Downstream, the wire is being handed over to a coiling mechanism. Wire is coiled in a container called a reelette. The reelette concept allows wires of various lengths to be treated as one length by downstream termination modules, thereby conserving machine movement and process time. When coiled, the wire is cut and passed to the transfer line for wire end termination. Wire end termination consists of an automatic transfer line and wire end finishing modules positioned on one or both sides of the line. Modules for stripping, crimping, lugging, sleeving, adding routing aids, tie wrapping, and inspection are available. All end finishing operations are housed in mobile tooling carts for ease of service and selection of finishing sequences. Developed from proven semi-automatic tools, this wire stripping module strips single conductor, stranded, non-shielded wires. Strip length and gauge adjustments are automatic, and each wire strip is verified. The crimp module combines proven automatic feeding devices with a choice of crimping tool devices for 16, 20, 22, and 22D pin or socket terminals. Each crimp contact is tested automatically. At the sleeving module, an identification sleeve is selected from up to 10 colors and placed on the wire. After sleeving, the wire moves to a shrink module, where the sleeve is heat shrunk for a snug fit. A routing aids module can be added to wrap colored tape around the wire end for later use in manual routing operations. After wire end finishing, the wire advances to the end of the transfer line, where finished wires can be loaded into tote boxes, or they can be stacked into a kitting module called a carousel. The carousel serves as a buffer storage for transporting kits to automatic or manual processing stations. Each carousel has 10 columns, each capable of holding 50 rillettes. Wires can be programmed to be stored in specific sequences according to the requirements of the next assembly level. Rillettes are loaded into the carousel by a stacker and indexing mechanism. Each column of rillettes is removable as a unit. Loaded carousels detach easily from the stacker and roll to the manual routing work areas. To provide kits with one end of the wires inserted into a connector, a first end insertion module can be added to the carousel stacker and indexer. A connector insertion device, called the insertion head, consists of a multi-axis manipulator and a quill set for inserting contacts into the connector. As the rillette is moved into position for placement into the carousel, the manipulator grips one end of the wire, places it into a quill, and then inserts the contact into a connector mounted on top of the carousel. Because the quill does not touch the connector, environmental seals, the grommet, and the connector inserts are protected. To hold the connectors for first end insertion, a crown is added to the top of the carousel. A vision system helps the manipulator locate the connector within a coordinate system that locates the hole positions. A completed kit can consist of up to 100 wires from 2 adjacent columns inserted into one connector. From raw components to selectable levels of wire processing, the wire vector represents unmatched application versatility coupled with high throughput and quality control. MTS Vektronics in San Diego County, California is the newest member of the MTS Systems Corporation family. MTS and its subsidiaries provide systems for testing the dynamic properties of materials and structures and for automating the factory floor in the discrete manufacturing industries. The common thread that runs through all of our products is the precision control of forces and motions. MTS and its subsidiaries have over 1,300 employees worldwide, 1/3 of which are degreed engineers specializing in control systems design, mechanical systems development, and software control. It's this technical strength, coupled with modern development and manufacturing facilities, that provide an excellent environment for the advancement of wire processing automation. Plus, doing business with MTS and MTS Vektronics is good business. As a company with over $100 million in sales, we're big enough to put the best in design, manufacturing, support, and service into our products and in our business relationships. Yet, our structure allows us to maintain the comfortable style of the small company. With outstanding technical and service support in all regions of the world, MTS has grown a worldwide base of satisfied customers. MTS Vektronics, developer and manufacturer of advanced wire processing systems. To find out how the wire vector technology will connect with your wire shop productivity and quality needs, contact an MTS sales engineer.